Hi, I'm Austin Langley, and I am currently in the Air Force. And one of the big reasons behind that, or the driving factor behind that, is my father. He was a pilot in the United States Air Force. He's also a pilot in the airlines, and he kind of opened my eyes to what I wanted to do in the future. So a little bit about me is I like to, of course, be outdoors. I like to, being 25, I like to drink. And then I also like to hike, like I said earlier, being outdoors. Other than that, we're going to go over a physics lab that we did today and some of the experiments that contained inside of it. So some of the experiments we did, we measured the mass and volume, and from that we were able to get the density and describe if it was able to float or if it was able to sink. So the first one we did, of course, and I'm only going to run through a few of these, is wood. So wood came out to be a mass of 13.30 grams, and the volume was 15.6 milliliters, or in centimeters, it's cubic centimeters. So take that, if you take the mass divided by the volume, you get a density of 0.85. Some other numbers after it, I'm going to spare you the numbers, but that equates to it being able to float because it disperses more of the water than the actual mass itself. Some of the correlations I realized between some of the density and the ability for the object to float and sink was, of course, if the density itself was below 0, it allowed the object itself to float. If the density was above 1, it actually allowed the object to sink. It was more heavy than it actually dispersed the water, so it sunk right to the bottom. The object for the wood that I spoke about earlier, the density came out to be 0.85, which most closely resembles the oak wood. And last but not least, we move on to some of the substances and densities that chart we have at the very end. And a few questions I did have was from the aluminum, cork, and plastic places where I got differing numbers for my density than what was actually shown on the chart. For aluminum, I got 5.09, where the aluminum was 2.70 on the chart. And I ran through the experiment a couple times, kept getting 5.60 for the mass and 1.1 for the volume of milliliters or cubic centimeters. And that would equate, again, once you take the mass divided by the volume, to about a 5.09 grams per cubic centimeter. So I kept getting that where the density on the chart was 2.70, and then also with the cork and the plastic, with the plastic I got within the range, but I did have a few questions at why that range was able to go from 0 to 0.75 to almost 3 or almost 4. That allows it for a whole wide range of ability to float and ability to sink. Now the only thing I could think of for that and the rubber is that this chart takes into different accounts of rubber and plastic, but I just don't know. If that could be explained in the future, that would be great. Thank you.